So what we're going to talk about today is some reference angles. The definition for reference angles, that would be angles formed by the terminal side and the x-axis. And then also write in parentheses, please, that they always are positive and acute. And I know you guys remember from geometry that acute means less than 90 degrees, okay? If you want to, just the reference angle is the fastest way to get to the x-axis. Okay, the actual definition is the angle formed by the terminal side and the x-axis, but just think of it as being the fastest way to get to the x-axis, the fastest route, okay? So I have, right underneath this, there's 4 sets of axes. I want to show you a reference angle in each quadrant, so we're going to make up some examples of our own. So we're going to, for the first one, we're going to stick to quadrant 1. Quadrant 1 is between 0 and 90 degrees, right? So let's say that I choose, let's go with 30 degrees. We'll say theta is 30 degrees. 30 degrees, that's a third of the way up. So we'll put that right about here. Okay, this is 30 degrees. Now your reference angle is the fastest way to get to the x-axis. Has to be x, not y. So if I were to start at the terminal side, right, the fastest way to get to the x-axis would be to go straight to this, which we know is 30 degrees. So I know it's a little confusing, but your reference angle is 30 degrees. Okay, quadrant 1 is weird. Quadrant 1 is very weird. So let's go to quadrant 2. Quadrant 2, we know is between 90 and 180 degrees, right? So let's say we're in quadrant 2. We'll go with 100, right? Nice number. We'll say theta is 100 degrees. 100 degrees is really close to 90. So again, you always start this way. 100 degrees would be, let's say, right, maybe even closer than that. Let's say it's right there. So this is 100 degrees. It is the fastest way for me to get to the x-axis, right? That's what a reference angle is. So if I were to start on my terminal side, let's say right there, the fastest way for me to get to the x-axis would be for me to go this way. So if this piece here is 100 degrees, if I were to go all the way around, it would be 180. So you would do 180 minus 100 degrees to figure out what this piece in blue is. So in quadrant 2, your reference angle, well, not always, but if your angle is 100 degrees, the reference angle is 80 degrees, because you would have to go another 80 degrees to get to the x-axis. Quadrant 3. Quadrant 3, we'll say that quadrant 3 is between 180 and 270. Usually, not always, right? Because, again, we have all these coterminal angles, and you have negative angles and everything. Let's say that theta is, we'll go with 225. Okay, so 225 is actually right smack in the middle of the two of them. This whole thing is 225. My reference angle would be this piece here, because that's the fastest way for me to get to the x-axis. So if this whole thing is 225, I know this is 180. I would do 225 minus 180 to give me a reference angle of 45 degrees. In a second, when we do each quadrant in a second, I'm going to give you the actual rule for it if you want to follow rules. If you understand what a reference angle is, and you understand how the quadrants work, the 0, 90, 180, 270, 360, then you probably can figure it out on your own using your calculator. But if you are a rule person, I know some of you like having something to memorize, then I'll give that to you in a second as well. Okay? And then fourth quadrant. Now remember, it's not always going to be these angles. I'm just picking random angles. Quadrant 4, that's what I am up to now, is between 270 and 360. So let's say we pick, let's go with 340, right? 340, so you start here, you go all the way around, and you get pretty close. Ooh. You get pretty close to where you would finish the entire circle, right? This whole thing is 340. Your reference angle, the fastest way to get to the x-axis would be this little piece here. So you went 340, you have to get to 360. So to figure out what your angle is, you would do 360 minus 340. So for this example, the reference angle would be 20 degrees. Again, it's the fastest way to get to the x-axis. How many more degrees would you have to go to get to the x-axis? Okay, so now let me explain something very quickly. You know how last week we said the sine of 30 is 1 over 2, the sine of 60 is the square root of 3 over 2. All of these numbers, they all repeat over and over and over again. They repeat from 0 until 90, and then they like reset in quadrant 2. And then they reset in quadrant 3. And then they reset in quadrant 4. They're all the same numbers, it's just whether it's positive or negative. So if you remember our chart from last week, all students take calc. In quadrant 1, everything is positive. In quadrant 2, only sine is positive. In quadrant 3, only tangent is positive. And in quadrant 4, only cosine is positive. Okay, we're going to use that in a second. So quadrant 1, let's just talk about quadrant 1. The rule for quadrant 1, again, that was that first example that we did, is that your reference angle is whatever theta is. So let's pick, again, I'm going to pick a random example. Something that's in quadrant 1 would be 60 degrees. So let's say that theta is 60 degrees. That would be right about here. It's about 2/3 of the way up. 2/3 of the way up to the 90, right? Your reference angle, so actually, you know what, let's do this quick. I want you to write down here, sine 60. This just goes with the example that I'm choosing. Cosine 60, tangent 60, okay? I'm going to do the reference angle in blue. The reference angle is the fastest way to get to the x-axis. So that would be right there, and that angle measurement is 60 degrees. So if theta is 60, which is in quadrant 1, the reference angle is the same thing, is 60 degrees. Okay, I know that's a little weird. So now it's going to sound even weirder. The sine of 60 is the same thing as the sine of 60. The sine of whatever your theta value is going to be the same thing as the sine of the reference angle. It's just a matter of whether it's positive or negative in that quadrant. Okay? So just copy this for now. Sine 60 equals sine 60. Cosine 60 is cosine 60. It'll make more sense when your reference angle is different than your theta value. Okay? Let's go to quadrant 2, because that was weird. Always makes more sense when I get to quadrant 2. So an angle in quadrant 2, let's go with 150 degrees. I'll give you the general rule in a second. So 150 degrees, you start here and you end right about here. This is 150. You know that if you were to go to the x-axis, that entire thing would be 180, right? Your reference angle is right here, is this piece in blue. So if you go 150, you have to see how much more would you have to go to get to 180, because 180 would be that straight line. So you would have to go another 30 degrees. So your reference angle is 30 degrees. Your general rule in quadrant 2 is that your reference angle is equal to 180 minus whatever theta is. 180, and then you back up however much. Okay? So now I want you to write, I should have had you write this down before. You're going to put 150 in for all of these because that's the number that I chose, 150, 150, 150. So this is where this gets a little different. So sine of 150 is the same thing as sine 30. Cosine 150 is the same thing as cosine 30. Tangent 150 is the same thing as tangent 30. But now I have to see whether it's positive or negative, right? We know that 150, you don't have to copy this, but 150, that's in quadrant 2. And 30 is in quadrant 1. So the sine of 150 is in quadrant 2. In all students take calc, quadrant 2, only sine is positive. So sine would be positive, which means that the sine of 30 matches it. Because sine of 30 is in quadrant 1. Your right side over here, all of your reference angles are going to be positive and acute. They're all going to be in quadrant 1. So these are all going to be positive on the right until, for example, cosine 150. The cosine of 150 is in quadrant 2 where only sine is positive. So to make up for that, you put a minus sign. Okay? Tangent of 150. You're in quadrant 2, only sine is positive, so this would be negative. Now what you can do in your calculator, if it makes more sense to you in the calculator, remember you have to be in degree mode, okay? But if you were to type in sine of 150, you would get 0.5. If you were to type in, sine of 30, you would get 0.5, right? Sine of 150 is the same thing as sine of 30. 0.5 is 0.5. Now, if you were to do cosine of 150, the cosine of 150, you're going to get that 0.8660 number, which I told you could memorize. That is the square root of 3 over 2. Okay? The only thing is you're going to get a negative for that. Sorry. Negative 0.8660 because it's in quadrant 2. So cosine will be negative. If you do the cosine of 30, you get positive 0.8660, which is a positive square root 3 over 2. So the cosine of 150 is the same thing as the cosine of 30, but you have to negate the cosine of 30 in order to make it the same number. Okay? The same exact number, meaning the same positive or negative. Same thing with tangent. You're in quadrant 2, only sine is positive, so you put a negative in front of the tangent. Okay, let's look at quadrant 3. It makes more sense by the end, I promise. Quadrant 3, again, we're between 180 and 270. So let's just choose 200. So we'll say theta is 200 degrees. I'll give you a general rule again in a second. So 200 degrees, that's only 20 away from 180, so I'm closer to the x-axis. So this piece here, that's 200 degrees. My fastest way to get to the x-axis would be to take this root right here. You know that this is 180. So you went over the 180 to get to 200. which means you went an extra 20 degrees. So your reference angle would be 20 degrees. Your general rule in quadrant 3, to find the reference angle, your reference angle is theta, so theta comes first in this one, minus 180. Theta minus 180. So now down here, again, our example was 200 degrees. So you're going to put 200 in for all of these. Okay. So the sine of 200 is the same thing as the sine of 20. The cosine of 200 is the same thing as the cosine of 20. It's the cosine, the sine of the reference angle, cosine of the reference angle, tangent of the reference angle. Okay? Now, when we're in quadrant 3, all students take calc, right? Quadrant 3, only tangent is the one that's positive. So sine and cosine, you have to negate. Okay? Tangent's positive, so you leave it alone. It doesn't change signs. And last quadrant is quadrant 4. That would be something in between 270 and 360. So let's go with theta being 320 degrees. So 320 is kind of in the middle, right? You start here, you go all the way around. Now your reference angle is the fastest way to get to the x-axis. So you know that this is 320. You know that this is 360. So your reference angle in here, you would have to go another 40 degrees. The general rule is to find in quadrant 4, you would do 360. Reference angle equals, just so we don't get confused. Reference angle equals, you would do 360 minus whatever the theta value is. So 360 minus 320 is 40 degrees. So your reference angle is 40. So what that means is that the sine of 320 degrees, the cosine of 320 degrees, and the tangent of 320 degrees we can figure out as a function of a positive acute angle, meaning your reference angle. So the sine of 320 is the same thing as the sine of 40. Cosine 320, same thing as the cosine of 40. Tangent of 320 is the same thing as the tangent of 40. Now, though, we have to figure out whether it's positive or negative. All students take calc. This is quadrant 4. Only cosine is positive, so you put a negative in front of the sine and the tangent. Okay? So let me just show you 3 quick examples. Okay, so rewrite the following as the function of a positive acute angle, meaning the reference angle. So what we did on the bottom of those last pieces. So the sine of 200 degrees. Your reference angle, so if you want to follow the rules, right, if you are a rule person, 200 degrees is in quadrant 3. The rule for quadrant 3 is theta minus 180. So you would do 200 minus 180 to figure out that your reference angle is 20 degrees. So the sine of 200 degrees is the same thing as the sine of 20 degrees. We actually did this one up here, but that's okay. Now, though, you have to see whether it's positive or negative. So we just said quadrant 3. Quadrant 3, only tangent is positive, so this gets negated. And that's it. You're just not doing all of them. Okay, but when we did it for each of the quadrants, we did sine, cosine, and tangent. Now it's just asking you to do just the one. Letter B. Tangent of 135 degrees. 135 degrees is in quadrant 2. The rule for quadrant 2 is that you would do 180 minus theta. So in this case, theta is the 135. So 180 minus 135 is 45 degrees. So that's your reference angle. So the tangent of 135 is the same thing as the tangent of 45 degrees. But remember, we're in quadrant 2. All students take calc. That's quadrant 2. Only sine is positive, so you put a negative in front of the tangent. And then what you can do to check it, if you type in tangent of 135, press enter, and then negative tangent 45, press enter, you should get the same exact answer. You would get -1 for both of them. And then the last one, cosine of 300 degrees. 300 degrees, that's in quadrant 4. In quadrant 4, the rule is that you would do 360 minus theta. In this case, theta is 300, so 360 minus 300 is 60 degrees for your reference angle. Again, if you can figure it out in your head, or if you want to draw a picture, then that's totally fine. So the cosine of 300 degrees is the same number as the cosine of 60 degrees. But remember, we're in quadrant 4. All students take calc. Quadrant 4, only cosine is positive, so you don't put a negative in front. If you want to put a positive, you can, but you don't have to. Okay? If you're doing this on Delta Math, I suggest you don't put the positive. It might confuse the computer, but if that happens, then just let me know, and I'll totally take full credit for it. Okay? Let me know if you have any questions. You're going to have a homework tomorrow. It's going to just ask you for what the reference angle is, and then it's going to be like the 3 on the bottom. Okay? Have a great day.